Continuing our work with series, we're now going to be looking at an alternating series. At the end of this lesson, you'll be able to determine whether an alternating series converges or diverges using the alternating series test. Alright, first of all, an alternating series is a series in which the terms are alternately positive and negative. They won't always be negative, they won't always be positive, they switch. An example of that, if I had sine, let's do the series n equals 1 to infinity. If I had the sine of n pi over 2, what would happen for the first term? I'd get sine of pi over 2, which is 1, and then I'd plug in 2, I'd get the sine of pi, which is 0, and then I'd plug in 3, I'd get the sine of 3 halves pi, which is negative 1, and then I'd get 0, and so forth. And so you'll notice what is happening is my terms are alternating between positive and negative, so that would be an alternating series. What this would look like and actually another one I'm going to go ahead and give you. Let's say I have n equals 1 to infinity. Another one would be negative 1 to the n plus 1 times 1 over n. And if I, again, plugged in terms of this, if I plugged in 1, this would turn to positive, and I'd get 1. And then if I plugged in 2, I'd get negative 1 times 1 half, which would be negative 1 half. And then if I plugged in 3, I'd get 1/3. And then if I plugged in 4, I'd get negative 1/4, and so forth. So you'll notice again this is an alternating series because we are alternating between positive and negative terms. All right, what we are going to be doing is figuring out whether a series converges or diverges in this video. We will in the next video then, if the series converges, we will be looking if it does so absolutely or conditionally, but not yet. All right, the alternating series test. This will look a little bit formal and wordy, but we'll dig through it and figure it out. This series, negative 1 to the n plus 1 times u sub n. This part right here is going to be making it alternate, and you'll notice we just have different terms of the series sequence, and then obviously if you make it a series, you're adding them together. It's going to converge if all three conditions are met. So we have to have all three of these. If even one of them is not met, the series diverges. And you'll notice as I'm going through this, the part next to the negative 1 is my u sub n, so that's what we're going to be looking at when we figure this out. So if the u sub n is always positive, if this part right here, if it says 1 over n or 1 over n squared, if I plugged in the terms for n and I keep getting a positive number, then that would meet the criteria. Okay, the next one, this says that u sub n is greater than or equal to u sub n plus 1 for all n greater than or equal to capital N for some integer n. What that basically means is that the terms of the sequence are the same or they are decreasing. And again, if you found it, I know we had something like this when we did the integral test. If the first couple of terms aren't decreasing, but then after that they start decreasing for the rest of time, this would hold. The way that we are going to determine this is we are going to show that the derivative is always less than 0. So I'm just going to put again, we want it to be a negative number, because if u prime is a negative number, that would mean my series is decreasing. So that's the way we'll figure that out instead of writing out the terms of the sequence. And then the last thing is that u sub n has to approach 0. And basically what that means is if I take the limit as n approaches infinity of that sequence or of that function, we should get 0 for an answer. And again, all three of those tests have to be met. All right, so let's look at a couple examples. We want to determine if the alternating series converges or diverges, and again, because of this negative 1, that is going to make it toggle back and forth between a positive and negative number. So first of all, I'm going to identify my u sub n. My u sub n would be 1 over n. It's the number that's right here. Okay, so test 1, I want to make sure that u sub n is always positive, and you'll notice if we plug in 1, 2, 3, we'll get 1, and then we'll get 1 half, 1/3, 1/4. I'm always going to get a positive answer for my sequence, so check 1 is met, we're good. Number 2, we need to make sure that u sub n is decreasing, and the way that we are going to do this is take u prime and the derivative of 1 over n, if you want to rewrite that as n to the negative 1, that would be negative 1 n to the negative 2, or we could rewrite that as negative 1 over n squared. And now if you'll look at this, because if I square n, that will always be a positive number, but that negative is always going to be in the way, u sub n will always be negative, or I can put it will be less than or equal to 0. So since that check is matched. Right? And then number 3, we just want to make sure that u sub n approaches 0. So we'll find the limit as n approaches infinity of 1 over n. And you'll notice if we do plug in infinity, I'd get 1 over infinity, which does approach 0. So we did find the limit is equal to 0. So all three checks are made. So we will say this series converges. So we are all set with that one. All right, let's try another one. The series n equals 1 to infinity of negative 1 to the n times n plus 2 over n minus 7. Again, if I started writing the terms of the sequence, I would alternate between a positive and a negative answer. So we are going to, first of all, just identify our u sub n. Our u sub n would be n plus 2 over n minus 7. My first check would be checking the terms of the sequence. If I plugged in, I'm just going to start finding some of the terms of the sequence. The first term, since I'm starting at n equals 1, the first term would be 3 over negative 6, which is negative 1/2. I already got a negative number, and all of the terms of the sequence have to be positive. So all of a sudden, check 1 did not work. I would say all terms are not positive, and I could be done. I am just going to go through the other two checks just to give us practice going through the checks. The next thing that I would be looking for is to making sure that u sub n is less than or equal to 0. So the way that I would do that, we basically, again, we're trying to find that u sub n is decreasing. And if I did this, I would have to use the product rule. The quotient rule. F prime would equal 1, G prime would equal 1. So if I was using the quotient rule, f prime times g, 1 times n minus 7, minus f times g prime would just be minus n plus 2 all over g squared. And then when I do that, I'm going to get n minus 7 minus n minus 2 over n minus 7 squared. My n's cancel out. I end up getting negative 9 over n minus 7 squared. And once again, since I'm squaring the denominator, that will always be positive, but negative 9 will make it always negative. So I found out that this will always, u sub n, or the derivative of u sub n will be always negative. So actually this check does work. U sub n is decreasing. And then if I wanted u sub n to approach 0, we would find the limit as n approaches infinity of n plus 2 over n minus 7. I would get infinity over infinity, so I'd get to use L'Hopital's rule. And if I did that, I would get 1 over 1, which equals 1. And so notice I did not get an answer of 0. So actually this check does not work either. So either one of those, I could say this series diverges, and I could use either one of those first or third tests to tell that it doesn't. So hopefully now you can tell whether an alternating series converges or diverges using the alternating series test.